Today we begin Unit 6. So Unit 6 is all about electrochemistry. By the end of this recording, hopefully you'll have an idea of what goes on during a redox reaction. All right, and you'll know you got this when you can correctly identify reduction and oxidation reactions and kind of like sort them. So what does this word electrochemistry make you think of? Kind of, break it down, that sort of thing. What are some parts in there? If you listen to this beginning part, electro, kind of sounds like electricity. All right, and then chemistry we know has to do with chemicals. So electrochemistry is the study of chemical conversion to electricity. All right, so look at these reactions down below and just, kind of absorb them a little bit, because these are kind of the primary reactions that take place during electrochemistry. Not necessarily always with zinc and copper, but the format of what's going on here. So you can kind of see you've got one solid metal being broken apart into its ion and some electrons. And then you have a different ion combining with electrons to come back into a solid metal. All right, so you can think of it as, here we've got chemical to electrons, which is the basis of electricity. All right, so when you plug something in and you have electricity flowing through it, it's actually electrons that are moving around. And then here you've got electricity, the electrons getting converted back into a chemical. All right, something I'm going to throw on the board here when you think about this, and I bet you guys will this might make it sink in a little bit. Just think about any time that you've used something with a battery. So like a laptop, a cell phone, a camera, an Xbox controller. All right, batteries work via electrochemistry. The battery itself has chemicals inside of it that is converted into the electricity that runs your laptop, your game controller, that sort of thing. So here's a good old definition for you. Electrochemistry is the study of the conversion of chemical energy to electrical energy and vice versa. And then this occurs via redox reactions. So those reactions we saw on the last slide, that's what those are. Redox reactions. All right? And that word comes from the fact that there are two halves to these reactions. All right? There's a reduction half and an oxidation half. And these are some terms we're going to focus on writing next. So pause the video if you need more time to get some notes down. But oxidation, all right, I'm trying to give you some tricks as far as how to remember these, but oxidation is when an element loses electrons. All right, so when we are looking at those two half reactions we saw before, the zinc was going through oxidation. All right, because zinc was going from being solid to a positive ion and releasing some electrons. All right, some tricks that I've used in the past when I've had to memorize this sort of stuff for tests and quizzes is the phrase Leo, like Leo the lion. All right, lose electrons, oxidation. All right, so that's one way you can try to remember this. Reduction, on the other hand, is the exact opposite. An element is going to gain electrons. All right, so you're going to start out as your positive ion, and you're going to pick up some electrons to turn back into that solid metal. All right, so gain electrons, reduction, or GR. So lions go GR, Leo goes GR. All right, so that's something you can do to help you remember what happens during these. All right, because if I give you any reaction, doesn't necessarily have to be zinc turning into zinc 2+ and 2e minus, as long as I show you a metal that is getting converted into an ion with some electrons being released, that's oxidation. And then if I show you the opposite of that, a metallic ion picking up electrons to turn back into its metallic form, that's reduction. So spend some time writing this down. Pause if you need more time. Another concept that is important to understand related to oxidation is there are some rules related to whether or not something is likely to oxidize. Certain elements are much more easily oxidized than others. So some are better at giving away their electrons. All right, we know all metals form positive ions, but some are much more apt to do it than others. All right, so this table here, you don't need to write this down and have it memorized, but you do, when you see it, need to be able to interpret it. All right, because you will see and be given this table multiple times on tests and quizzes. So really what it is the higher on the table, the more active it is, the more likely that chemical will undergo oxidation. All right, so lithium is the most likely to oxidize metal, and gold is the least likely. All right, so you can think of at this top end of the table, oxidation is most likely going to occur. At the bottom end, reduction is most likely to occur. All right, so highly active means it lends well to oxidation. Least active means it lends well to reduction. So an example of how you might use people is of the metals Pb, which is lead, Hg, which is mercury, Na, which is sodium, and Ca, which is calcium, which is the most difficult to oxidize. All right, so if you remember, top of the table, these guys want to oxidize. Bottom of the table, these guys want to do the opposite. They want to reduce. All right, so if we're looking for most difficult to oxidize, we're looking for the one that's lowest on the table. So let's find all these. So we've got lead, mercury, sodium, and calcium. The one lowest on the table is your mercury. And that would be the right answer there. Last bit of vocab to cover here is this definition of the two types of electrochemical cells we're going to deal with in this class. We're going to get into much more detail on these as we move forward, but just because I know you guys are going to have some questions related to this on a quiz coming up, you want to know that voltaic cells, also called galvanic cells, all right, they convert chemicals into electricity spontaneously. What that means is they follow that reactivity series. If there's two metals involved, the one going oxidation is going to be the most active metal, and the one undergoing reduction is going to be the least active. All right? An electrolytic cell is a cell that can convert chemicals into electricity non-spontaneously. You have to provide some energy to get this to happen. But what you're doing is you can take that reactivity series and reverse what's supposed to happen. All right, so say you wanted to oxidize gold. All right, you're going to need to use an electrolytic cell because there's no metal that you can throw in there that's going to force gold to oxidize spontaneously. All right, so voltaic cells follow the reactivity series. Those occur spontaneously. Electrolytic cells require energy to reverse that reactivity series. So again, good terms to write down. We'll get into the details behind these more as we continue through this unit. And just an example of how you might use this information is which of the following would most likely be a galvanic cell? All right, so a galvanic cell, another word for voltaic, that occurs spontaneously. All right, so that means it's going to follow your reactivity series. So let's look at cobalt and aluminum. So cobalt There's cobalt. So if we want to oxidize that, and aluminum is going through the reduction. All right, we remember how this table works. These guys want to oxidize, and these guys want to reduce. So this is going opposite the trend of our reactivity series. So this one does not work. All right, that's going the reverse of what we would expect. So let's look at barium and copper. All right, so barium is going to oxidize, copper is going to reduce. All right, that is going in the right direction. So let's just double check, make sure the other ones don't end up passing along. All right, so we've got lead and lithium. So here, where did lead go? There's lead. We want to oxidize that, and then lithium we want to reduce. Yep, that's definitely backwards, so that's something that would happen in an electrolytic cell. And then we've got tin and magnesium. Tin, magnesium. That also goes backwards for our reactivity series, so that's not going to happen spontaneously. So the only one that works here is B, the barium reducing copper. So hopefully how to use this reactivity series makes sense, and make sure you can recognize if something is an oxidation versus a reduction reaction. Have some practice for you in class.